Good day, everyone. So today we'll be moving to real numbers. Real numbers. So let's quickly take the introductory part. What are real numbers? Real numbers are numbers that can be placed on a number line. They are simply the combination of rational and irrational numbers. Simple as that. They are the combination. Real numbers are just the combination of both the rational and irrational numbers. And they can be placed on a number line. The more we go further into this video, the more you understand what by the number line, rational and irrational number. So you'll be able to understand these terms. And also we can also call it real numbers are those numbers that are real. That's from my own way. Numbers that are real. In the sense that they are not fake numbers, they are real numbers. So at the same time, we have what we call imaginary numbers. Imaginary numbers are just like numbers that are unreal. They cannot be expressed on a number line. That's like direct opposite of real number. There are numbers that are unreal. These are what I call fake numbers. So they cannot be represented on the number line and are commonly used to represent complex numbers. So these are examples of imaginary numbers. I told you they are numbers that are unreal. So before we talk about this real number, we must know what we mean by imaginary numbers. Since they are unreal and they are fixed and they are commonly represented by complex numbers. So these are examples. We have 4 called 5i, 3i. So I've been seeing something like that before. Something like this. So these are examples of imaginary number. And this I simply means square root of minus 1. So square root of minus 4 is going to give us 2i. So square root of minus 9 is going to give us 3i. These are imaginary numbers. And there is no way we can plot this on a number line. You cannot plot square root of minus 1 on a number line. It's not possible. So that's why we call them imaginary numbers. So everything here cannot be expressed on a number line, and they are called imaginary numbers. Let me quickly give example of real number. Real number can be 23 minus 12. These are real numbers. 6.99, 5/2, pi, etc. So these are examples of real numbers. Real numbers can be divided into two. We have what we call rational number and irrational number. So what are rational numbers? Rational numbers are numbers that can be put into fraction using 2 ratio. There's a number that can be put into fraction using 2 ratio. What do I mean by that? That is, you can say A over B. It is possible. Those fractions that you can use to put into this ratio is what we call rational number. So under rational number, we have different rational numbers. We have different rational numbers. And what are they? We have integers under rational. Integers. What are integers? Integers are just number that we use on the number line. We start from negative and positive. Negative number and positive number. All numbers are negative and positive. So it starts from minus 2, minus 1. You can start as from anywhere. So minus 2, minus 1, 0, 1, 2, and so on and so forth. Integers. Whole numbers now. Whole number is also under rational number. Whole numbers. So whole numbers are numbers starting from 0. Positive numbers starting from 0. Those are whole numbers. That's 0, 1, 2, 3, and so on and so forth. We also have natural numbers. So natural numbers is also form of whole numbers, but they are starting with 1. Natural numbers are whole numbers starting with 1, not 0. So we have 1, 2, 3, 4, and so on and so forth. These are under rational numbers. So all these numbers that we have here are all called real numbers under rational numbers, integers, whole numbers, and natural numbers. So what are irrational numbers? Don't forget, rational number are number that can be put into fraction of integers. So this one cannot be put into fraction of 2 integers. So it cannot be put into fraction of 2 integers. That is, they are not equals to a over b. So you cannot put it like this. That's why I call them irrational. From the word irrational, when they say something is irrational, literally when they say something is irrational, it means it's not making sense. So it cannot be put into 2 integer. It cannot be put into fraction of 2 integer like this. So let's quickly look at an example. Square root of 2 is one of irrational number. Square root of 2 will always give us 1.41213, going, it keeps going like that. So we also have e. If you press e in your calculator, it will give you 2.7182818 and keep going like that. Pi 2, our pi is 3.145 to keep going like that. So from this example, we can see that irrational number keeps going, it doesn't stop. So we can say irrational numbers are numbers that are non-repeating and non-terminating. I want to quickly clarify the meaning of non-repeating and non-terminating. What does it mean? I want to quickly understand it. For rational and irrational number, so this is for rational number, this is for irrational number. So let's quickly see what this means. For rational number, again, we've talked about rational number, so that's not anything. So for rational number, we have what we call, they are numbers. Anytime numbers are non-repeating and non-terminating, it belongs to irrational number. They are irrational number. What are the example? I gave you an example. This. So there are numbers that are non-repeating but terminating. They are non-repeating but they are terminating. So when they are like this, we cannot say they are under irrational number. No. Since they are non-repeating and they are terminating, if you have 3 over 4, you are going to get 0.75. So this 0.75 is non-repeating and it is terminating. You can see it is not repeating itself. 0.75. There is no number that are repeating itself and it terminates. 3 divided by 4 will only give you 0.75, so you can terminate it, like it stops. And also in a rational number can also mean that they are repeating but non-terminating. So rational number can be repeating but non-terminating. What do you mean by this? So when they are repeating and non-terminating, example will be 2 over 9. 2 over 9 will give you 0.2222. It keeps going, so we can say 0.2 bar. So this 0.2 bar means that it is repeating but non-terminating. You can see these two are repeating, keeps repeating itself on and on and on and on. So that means it is repeating but it's non-terminating. It is repeating itself and it does not terminate, it keeps going. So irrational number can be non-repeating but terminating and can also be repeating but non-terminating. But when you have a number that is non-repeating and non-terminating, that's irrational number. It does not repeat itself and does not terminate, it does not stop. That's irrational number. So let's go to the properties of real number. So what are the properties of real number? We have number 1, commutative property. So what does it say? It says if m and n are real numbers, then the addition is going to be, let's say this m and n are real numbers. So the addition for commutative property is going to be equals to m plus n could be equals to n plus m. That is to say, 5 plus 3 will give us same thing as 3 plus 5 for addition. You also have for multiplication. So for multiplication is going to look like this. M times n will be equals to n times m, which is 2. So that's one of the properties. So m times n will give us n times m. That is to say, 5 times 3, same thing as 3 times 5, which is 2. So that's that about the commutative property of real numbers. So what are associative property? What does it say? So it says if m and n, we are just using this as an illustration. If m and n are real numbers, so if they are real numbers, how are we going to know that m and n are having associative property? So it's going to be like this for addition. So for addition, it's going to look like this. M plus open bracket n plus r. Sorry, if m, n and r, they are 3 in associative. So we want to see how they are associated. So if m equals m plus n plus r will be equals open bracket m plus n close bracket plus r. Let's quickly test this. Let's say our m is 10. That will be 10 plus open bracket 3 plus 2, which will be same thing as open bracket 10 plus 3 close bracket plus 2. So if you check this both sides, they will give us same answer. Using board mass, the first one here, 3 plus 2 first to give us 5. Then we are going to add it to that 10. Add it to this 10 to give us 15. So 15 is this left hand side. The right hand side, if you look at it, bracket first, do the 5 bracket first. 10 plus 3 to give us 13, then plus 2. 13 plus 2 give us 15. So they are having 15, 15, which is correct. Addition. For multiplication now. Multiplication. The multiplication says mn open bracket n close bracket r equals to m into bracket n r close bracket. If you are saying this is also the same thing if you test it. So example is going to be equals to 10 times 3. That's mn. Mn, that means multiplication is in between them. Then the bracket 2, which is r, is the same thing as m, which is 10, open bracket n, which is 3, and then times r, which is 2. So if you do this side first, that will 10 times 3 will give us 30. Then since there's brackets between them, 30 times 2 give us 60. So let's take the other side. Do the bracket first. Now will be 3 times 2 give us 6. Then 10 times 6 give us 60. So both sides are giving us 60. That's multiplication property. This is what distributive property says. It says for 3 numbers which are m, n, r, let's say they are real numbers. These 3 are all real. They are real numbers. So distributive laws is saying that we can say m into bracket n plus r close bracket is going to give us m n plus m r, and also m plus n close brackets r is going to give us m r plus n r. Yeah, so this thing are almost the same thing. Look at this first one here. M into bracket n plus r. If you multiply this bracket, just like you want to open a bracket now, so that'll be m times n give us mn, plus we come, then you open another bracket, use the first m to open the second bracket, to m times r give us mr. So just like you're opening the bracket, that's distributive property. Yeah, to same thing. Use the m to multiply r, that's outside. Here now, use the m to multiply r, that's outside. M times r will give us mr plus then n to multiply the r that is outside. N times r will give us nr. So that's that about distributive property, identity property. So what does identity property says? So for m to be a real numbers, so addition in identity properties will look like this. Addition in identity property will always look like this. M plus 0 will always give us 0. So we can see here that this 0 is an additive property. That is, when you add m to 0, it always gives us 0. So we can say 0 is an additive property. Multiplication, you're going to have m times 1. So it's the same thing as 1 times m, which is same thing as m. So here we can say 1 is an additive identity because we are multiplying m by 1, and then we are multiplying m by 0. That's why 0 is an additive identity here. Since we are multiplying by 1 here in multiplication, that's why 1 is our additive identity. That's that about the properties of real numbers. Let's move on. Number line. Number line allows us to visually display real numbers by associating them with unique points on a line. So the points are what we call the coordinates. So number line just allows us to visually, that is to visualize real number by associating them with unique points on the line. So let me just draw a number line so we get familiar with number line. Draw a straight line. Draw a straight line. Then you find the middle by putting 0. So 0 will be at the middle. So these sides, that is this left hand side, will be for negative. This left hand side will be for negative. Right hand side, which this right hand side will be for positive. So let's start here. So this one will be 1, 2, 3, 4. So I'm using integers now. So this one will be minus 1, minus 2, minus 3, minus 4. So negative, that's for positive. Simple as that. So demonstrate minus 1 on the number line. So you just draw it from here. Then you draw it to minus 1 like this. So you stop on minus 1. Simple as that. If you have to represent greater than 1, so they say it's greater than 1, so it's going to be like this. Just draw a line like this to 1. Then you stop at 1. So if you say greater than or equals to 1, then this one will just change. Just make sure this one is colored very well. So this is greater than or equals to 1. So that's how to represent on a number line, as simple as that. And if you are given decimal, let's say 0.1 or 0.5, just find them on your number line, as simple as that. So then you draw your number line. So that's how number line works. You have the left hand side, you have the right hand side. The left hand side is for negative, the right hand side is for positive. Then you plot number on the line. That's how they call it, number line. Ordering real numbers. Simple as that. It is just the act of ranking the numbers, that is ranking the real numbers from smallest to the largest. When you rank real numbers from the smallest, the one that is the least, to the largest, the one that is the highest. There. Let me quickly give an example of how to order real numbers. Let's say we're having this minus 3, 2 over 3, minus 5.4, pi, 0, minus 9 over 2. So to order any real number, this is an example we are asked to order this number. We must order them on a number line. You must order any real number on a number line. And to order any real number, you must use a number line. So the first step is to convert each of the fractions that are here. Convert them to decimal point. That should be your first thing. So this one is not. So this one is still remain minus 3. So 2 over 3 to decimal 0.67. I'm approximating to 2 decimal place now. This is minus 5.4. You don't need to approximate it. Okay. Pi will give us 3.14. And 0, you don't need to approximate that. Then minus 9 over 2 is going to give us minus 4.5. So these are the values now. So immediately you are done arranging them to decimal point. That will be the first step. Don't forget, first step, arrange them in decimal point. Then the next step is to find these numbers on a number line. So we're going to use number line to determine these numbers. Did number line, last topic. So this will be 0. So this will be minus 1, minus 2. The negative here is minus 5, I guess. Minus 3, minus 4, plus 5, minus 6. So the right answer, which is positive. So now the next thing is just for you to put these numbers on this number line. So the number line, we arrange them for us. Minus 3, put it on the number line. It's going to be around here. Minus 3. 0.67 on the number line. Where is it going to be? 0.67 to be around here. 0.67. It's now up to 1. Minus 5.4. Minus 5.4 come around here. And 5.4 will come around here. 3.14, which is for the pi. 3.14 will be around here. These are 3.14. Then 0 will be here. Then minus 4.5. Minus 4.5 will be around here, the middle of this place. Minus 4.5. Now we have arranged everything. Now. So it's now for you to order them based on the number line. So look at the number line. That means minus 5.4 is the lowest. Following minus 4.5. Then minus 3 will be the next one. 0, 0.6, 3.14. As simple as that. So now we can write this out. Minus 5.4 be the first one. Then minus 4.5 will follow. So don't forget, minus 4.5 is from this thing. So you just write minus 9 over 2 because we want to order it now. Then minus 3 will follow. Then 0 will follow. After 0, we are going to have 0.67. So 0.67 is from this. So just write 2 over 3. Come on. And what else? 3.14, that's our pi. So just write pi. So this has been ordered This has been ordered using number line. So anytime you want to order anything, make sure you use your number line so that you won't make a mistake. Just first change them to decimal, then one by one put them on the number line that you have created. So after putting them on the number line, then you start arranging it based on the number line. The one at the left hand side will be the first one that you start writing. So that'll be from the lowest to the highest. From the left hand side, the more they are closer to the 0, the higher they become. That's why minus 3 is greater than minus 5.4, because it is very close to this 0. So that's that about ordering numbers. Now let's go to absolute value. Absolute value is a distance of a number from the origin of a number line. The distance of a number from the origin of a number line. Let's say this is the number line. We talked about number line. We've talked about number lines. So let's say this is the origin of a number line. So absolute value is now the distance of a number. Let's say this is a number now. Let's say this is 5. So the distance of that 5 from the origin of the number line. This is the origin of the number line to this distance from here to here is what we call absolute value. That is the origin of a number line. That is from here to here is what we call absolute value. The distance between them is what we call the absolute value. Simple as that. So we can say absolute value of A. This refers by this, which defines the magnitude of any integer A. So it defines the magnitude of any integer A. The absolute value of any integer, whether plus or minus, will be real numbers regardless of the sign it has. So anytime you have absolute value and you want to get to the answer, it will always be a real number. Whether it's having minus or having plus, the answer is going to always be a real number. It is always a positive value and not negative value. Note that. Absolute value is represented with modulus. This is what we call modulus. This sign, these two lines, these are what we call modulus. So it is represented with this modulus. Written like this. So this is absolute value of 1, absolute value of 2, absolute value of 3. So that's how you're going to write it. So that's our absolute value. That is distance between the origin to 1, which is 1. Distance between origin to 2, which is 2. Distance between origin to 3, which is 3. And always remember, absolute value is always positive and not negative. It is always positive. Remember that. Very, very important. So let's quickly find some absolute value. The absolute value of minus 1. So the absolute value of minus 1 will give us 1. I told you absolute value cannot have a negative as the answer. It's always a positive. So absolute value of minus 1 will give us 1. Absolute value of minus 14 will give us 14. Absolute value of 1 will give us 1. Absolute value of 0 will give us 0. Absolute value of 7 minus 2 will give us absolute value of 5. This modulus of 5, which is equals to 5. Absolute value of minus 3 times with 5 they always give us modulus of minus 15. Our answer is always going to be 15. So these are just simple illustration about absolute value. So anytime you are given minus to calculate, just change to positive. The absolute value of minus 1 will give us 1. Note that we don't have negative sign as answer in absolute value. It always change back to 1. If you see my examples, I want to calculate the absolute value of minus 3 on a number line now. So we already know it could be 3 or minus 3. That's absolute value of minus 3. So if you want to represent it on the number line, this will be 0, 1, 2, 3. And this will be minus 1, minus 2, minus 3. So representing these on the number line, absolute value of minus 3. So that will be from the origin to 3. Also from the origin to 3. So this is the absolute value of minus 3. But it cannot be two values. Why? We don't have negative as answer in absolute value. So that's why our answer is going to be 3. So absolute value of minus 3, number line is going to be 3. Operation on real numbers. So we have different operation on real number. Operation is just like the basic operation that we've been taught in school. Just normal operation that we all know about. So addition of rational number. So let's deal with operation on rational number first. So operation on rational number. So let's look at operation on rational number now. So operation on rational number, we have addition of rational number. So let's look at addition of rational number first. Addition. What does addition says? So joining two quantities into a single quantity. That's just all about addition. When you join two quantities to make it single quantity. Let's say you're having 2 over 9 plus 4 over 9. It's always give us find the LCM. That will be 9. 2 in 9 in 9. This 9 in 9 to give us 1. 1 times 2, 2. Plus 9 in 9, 1. 1 times 4, 4. So 2 plus 4, that will give us 6 divided by 9. So that's our final answer. So addition of rational number. This is a rational number. And this is also a rational number. So when you add 2, addition of rational number, it is still going to give us rational number. Simple as that. Subtraction now. So for subtraction, almost the same thing as addition. Subtraction is just about subtracting two quantities to make it a single quantity. When you subtract two quantities to make it a single quantity, that's what called subtraction. Same thing, let's use 2 over 9 minus 1 over 9 here now. So that will give us, find the LCM, that will be 9. 9 in 9, 1 times 2, 2. 9 in 9, 1 times 1 minus 1. So our answer is going to give us 1 over 9. So you can see that we got a rational number here too. So that means subtraction of rational number from rational number will always give us a rational number. Multiplication of rational number. What does it say? It's just combining several quantities into just single quantity. When you combine several quantities to make it single quantity, it might be 2, might be 3, might be 4. So you combine several quantities to make it single quantity. It is referred to as product, which is referred to as product. So let's see, it will be 2 over 3 times 4 over 5. So this is just simple arithmetic. Multiply numerator with numerator and denominator with denominator. Numerator are 2 and 4, so that will be 2 times 4, that will be 8. Denominator are 3 and 5, 3 times 5, 15. So you are still going to get a rational number. That is, multiplication of rational number plus rational number will give us rational number. Division now. Division is like opposite of multiplication. This is splitting quantities into smaller value called quotient. So when you split quantity into smaller value called quotient, you are doing division. Let's look at the example 2 over 3 divided by 4 over 5. These simple calculations too. When you have division in between two fractions, change to multiplication. That will be 2 over 3. When you change to multiplication, denominator here return to numerator and numerator here return to denominator. So that will be times 5 over 4. So multiply numerator with numerator and denominator with denominator. That will be 2 times 5. That will give us 10 over, and 3 times 2 will give us 12. You can either as it as 12 or you just change it to the lowest term. By saying 2 in this one will give us 5, 2 in 2 will give us 6, or saying 5 over 6, anyhow you want it. So you can see that division of two rational numbers will always give us a rational number too. We've talked about rational numbers, so now irrational numbers. So you are still going to have 4 operations here too. Same thing, just like the other one. So the first one, addition. Let's look at 2 addition of irrational number. I will still remember the example of irrational number that we have. So addition, if R is one irrational number, if R is one irrational number and S is another irrational number, so R plus S may or may not be an irrational number. So at this we are trying to see that addition of two irrational numbers may or may not give us irrational number. So let's look at two instances about that. 2 plus square root 3 plus 5 plus square root 3. So this is just like you are adding two irrational number together. You can find, if you look at them very well, they are irrational number, and this is like sort. You have, if you know, you have heard about sort before. So this is like performing simple operations on sort. Here, this square root is what we call root, and this 3 inside it is what we call radical. This is radical, this is root like the root of a plant. So this is the root and this is the radical. So now solving this, you're going to have, so add those one, add this plus this together, because this is 2, this is 5, they are from the same family. So add them together, that will give us 7. Then this one and this one, to add them together. But note, there is 1 in front of this and there is 1 in front of this. So simple sort formula says when you add them together, you also add them with the number in front of them. So 1 is here, 1 is here, so that will be 2. So that will be 7 plus 2 square root 3. Simple as that. So you can see this is irrational number. So this is a scenario that shows that addition of two irrational number might give us irrational number. So let's look at another scenario where we are going to get a rational number. Another scenario is 2 minus square root 3 plus 2 plus square root 3. So here now, don't forget, I told you, look at the one that are the same, from the same family. This is 2 and 2, they are from the same family. So this 2 is 2 plus 2. So that will give us 4. So look at this one, you must carry the sign minus 3 and then plus 3 square root 3. 31 is a 1 is here. So minus 1 plus 1, that gives us 0. And this one too will cancel out one another, because plus and minus, they will cancel out each other. You are in debt of 3 and you have 3. So the debt will cancel, so you have nothing again. So that means our answer is going to be 4. So here now, 2 addition of irrational number gives us a rational number. So addition of irrational plus irrational might give us a rational or give us irrational. So now subtract more like the addition one. If R and S are irrational number, so that is to say R minus S might give us a rational or irrational number. So that is same thing as addition. When you subtract R minus S, it might give us a rational number, it might not give us a rational number. Let's look at some example. 5 plus square root 3 minus open bracket 2 plus square root 3. So here now simple calculation as well. Let's open the bracket first. From BODMAS you have to open bracket. 5 plus square root 3 minus 2 minus square root 3. So here now do simple calculations, which is this from the same family. Minus 2, don't forget the sign, very very important. So that'll be 5 minus 2, which is give us 3. Don't forget this one is plus, this one is minus, so they will cancel out one another. So our answer is going to be 3. 3 plus 0 will give us 3. So our answer is going to be 3. So you can see addition of two irrational number gives us a rational number. This is a rational number. So let's look at in the sense that give us irrational number. So that will be 2 plus square root 3 minus open bracket 2 minus square root 3. So if we do this, it gives us irrational number. Let's solve it. Open bracket 2 plus square root 3 minus 2 plus minus times minus give us plus square root 3. So if you do this, these are from the same family. 2 and minus 2, so that will give us 0 definitely. That means they will cancel out one another, and what will remain will be plus square root 3 plus square root 3. And I told you, when you have something like this, 1 is in front of them, so don't forget add that 1 2 together, so that will give us 2 square root 3. So you can see we got irrational number here. Addition of subtraction of 2 irrational number gives us irrational number, or it might be give us rational number. So multiplication, same thing too. If R and S are two irrational numbers, if they are multiplied together, so it might be equals to or not equals to rational or irrational number. Same thing. It might be equals to rational or same thing as what we have been doing. Let's look at example 2 square root 3 times square root 3. So we have something like this. If you want to do multiplication in sort like this, so just multiply this and this, multiply the square together, and when you multiply square together, it will change to, like, the square root will be removed. So when two values that are having square root, when they are multiplying each other, the square root has to leave. So that's why we're having 2 times 3, which gives us 6. That is, I'm multiplying this 2 square root. I multiply 2 times 1, no 1 is here. 2 times 1 it will give me 2. Then square root 3 times square root 3 is going to give me 3. I told you before. It's just a rule in sort. When you multiply 2 square root together, something that has 2 square root with the same number inside, when you multiply them together, it's going to give you the number inside. That is going to give us the radical inside. So that's why we're having 3. So 2 times 3 gives us 6. This is a rational number. Let's look at another example that will give us a rational number using multiplication. So let's say we're having 2 square root 3 times square root 2. So in this kind of situation, I told you these 2 here, 1 will be here definitely. So that will be 2 times 1, which gives us 2. So here now we are having square root 2, square root 3, and square root 2. You multiply them together. You cannot remove, bracket cannot remove, because they are not, it's not the same radical that are inside. 3 is here, 2 is here, so it's not the same, so we cannot remove the square root. So that will just be square root 3 times 2 give us 6. So give us 2 square root 6. This is irrational. So it might be rational or irrational. Division of two irrational number. So same thing, if R and S are irrational number in division, so R divided by S may or may not give us irrational number. It may give us and it may not give us irrational number. It may be equals to another. Let's look at example 2 square root 3 divided by square root 3. So near simple calculations to change the division to multiplication. That will be 2 square root 3 times 1 over square root 3. So multiply them together. That's going to give us 2. This one will be over 1. So 2 square root 3 times 1 gives us 2 square root 3 divided by 1 times square root 3 gives us square root 3. So this one will cancel out this one, and the answer is going to give us 2. So you can see this is a rational number. Dividing 2 irrational number might give us a rational number. And let's see another 2 square root 3 divided by square root 2. So the division will change to multiplication. It always changes to multiplication. That's normal operation. 2 divided by 3 times 1 divided by square root 2. So this one will be over 1. This one will multiply numerator, will multiply numerator, which give 2 square root 3 divided by square root 2. So you cannot go much further than this. So this will be our answer, which is irrational. It could be rational or irrational. When you are dividing irrational number, let's look at the operation between them, between rational and irrational. So looking at operation between rational and irrational for additional. So that is to say addition of rational number plus irrational number will always give us irrational number. Note that. Let's check our example. Let's say having 5 plus e. We talk about e here the other time. This is rational, this is irrational. If I add them together, it's still going to give us 5 plus e. So there's no way we can solve it further. So that's it will give us irrational number. For subtraction, rational number minus irrational number, it always give us irrational number. Let's test this too. So note that it always give us irrational number. Same thing with the first example, 5 minus e, it always give us 5 minus e, which is irrational. Multiplication. For multiplication, rational times irrational number. But will always give us irrational number again. It always give us irrational number. Let's test it. 5 times square root 3. That's more like this is rational, this is rational, this is irrational. So it will always give us 5 square root 3. So it will give us 5 square root 3. Simple. For division, rational divided by irrational will also always give us irrational number. It always give us irrational number. Let's test it. Let's say having 5 divided by pi. So it will still give us 5 divided by pi. Cannot solve it further, which is irrational. So addition of rational, rational, and everything will always give us irrational number. Anytime irrational number is involved, the properties of non-repeating and non-terminating which belongs to irrational will not change anytime you are multiplying it with a real number. So we have come to the end of real numbers. So these are all we need to know about real numbers. Thank you for watching. Wish you the best of luck.